All right, so for our next topic, we are going to be, let me make this a little bit bigger for your benefit here. We're going to be solving equations. I gave you a couple simple ones yesterday to refresh. I want to make sure I give you some instruction on that. So that's what this is. Okay? So one of the things I like to do whenever we have equations, some people see them and they freak out, is I like to break them down. So when I look at my equation, the first thing I do is I kind of draw on this wall. I want to see the left and the right side completely separately. Then I ask myself, what is being done to x? X says x plus 4. Well, we learned that in algebra, we should be doing the opposite. So to undo this equation, we are going to subtract 4 from both sides. Leaves me with an x on the left because this adds to 0, and this is a 1. So my answer is x equals 1. If I look at the next example, which is similar, draw on my wall, what's being done to x is at subtraction, so I'm going to add 10 to both sides. Those of you who know this already, like the back of your hand, not a big deal. This is just a refresher for everyone who hasn't seen math in some semesters. So, x is equal to 13, and I'm done. Okay. Then they start to move the x around on us, and they say, okay, well, this is x plus positive 9. If I want to move this 9 to the other side, I always have to use opposites. This is x, 5, put in your calculator, minus 9 is equal to negative 4. For number 13, this is multiplication. Letters and numbers right next door, just like distributive property, is times. The opposite is division. So I'm going to divide both sides by 4 again. Here's that little wall, so you can see that what I'm doing to one side, I'm doing to the other. 12 divided by 4 is 3. Same thing here. Be careful. Some of you are going to see minus 8 and you're going to think add 8. No, this is times. What is being done to x? To get rid of it, I have to divide by the exact same number. So let's talk about this for a second back in this example. I went over the fact that I divided by 4, but the reason is because 4 divided by 4 is 1x. This is understood to be 1. We don't have to write it. Our goal is to get x by itself, which is what we ultimately do, provided that what we multiply and divide by is exactly the same, including the sign. So over here, negative 8 divided by negative 8 cancels actually down to 1x is equal to 4, or just x equals 4 if you don't write the 1. And then our last problem on this front page is to recognize that x divided by 4 equals 2. Wall, this is division. The opposite is multiplication. So notice I multiplied both sides by 4. I get x is equal to 8. All right, so now let's start looking at some variations of a little bit harder equations. When we look at this problem and I draw on the wall, I have to clean up my equation a little bit. We went over an example of this in distributive property, but when I multiply, this is a negative 1 times the negative 7, that's going to turn this into a positive 7. Bring down the x equals 14. From here, I will subtract 7 from both sides and come up with my final answer. So this is an example where we had to clean up one of the sides before we could do anything. In number 17, when I draw on the wall, the reason we gave you this example is you're going to think this is addition because that's what it says in front of x. But the truth is I need to move this minus 4 that is not being multiplied or divided to the other side. In order to move it to the other side, I'm going to have to do the opposite, which is to add 4. And that's where I got the 12. Okay. Number 18, divide both sides. So take a look. This is negative 2 right next to the x. Unlike the last one, the -4 had a plus sign between it. So since this is multiplication, the opposite is division. We want the same thing stacked on top of itself on both sides. All right, 6 more problems and we're done. Number 19, draw on the wall. This is what we call a two-step equation. Okay, bring that down. Two-step equation. The reason it's 2 steps is because first we have to isolate the variable. So let me pull out my little trusty color pen. Okay, so the first thing I have to do is get 2x all alone, because I got to get the x person by itself. So I'm going to add 1 to both sides. Bring down. These cancel. They add to 0. Hold on 1 second, y'all. We have another student coming in. Good morning, Jamal. Can you hear me? Jamal, are you connected through audio yet?
Yeah.
Okay, good morning. Hey, we're finishing up the notes. I'll be able to post these as a video in a little while. Okay? All right, so here we're going to be dividing both sides by 2 and get 3. X equals 3. This is another example just like it. My goal is to isolate the x term. To do that, to get rid of the +4, I'm going to -4. That's going to give me 9 is equal to 3x. And then recognize this is multiplication, so I'm going to divide next. Now, when we look at 21, I have done enough of these problems to realize that sometimes when we move to fractions, it panics students. Don't let it. Do the same exact procedure. This is the one that has the x in it. Okay, so what did I do? I isolated the term or person that has the x in it. Draw on my wall. I'm going to subtract 3 to keep everything balanced. What I do to one side, I do to the other. And now this is going to start to look a lot nicer. This is division, so I'm going to multiply both sides by 2. Now I have 2 over 2, which cancels to 1x. Or maybe you just write it as x. This is what it should look like. All right, last 3. Again, please don't panic over fractions, okay? Don't panic over fractions. If I have 4x, first of all, this 3 can actually go right underneath the 4. You don't even have to write it with the x, okay? What you should have learned in the past is that we're going to multiply by what's called the reciprocal. So I'm going to put in 3/4 here, and I'm going to multiply by 3/4 here. So when you look at this problem, if I draw my wall in, what I did on the left is the same as what's on the right. And the reason is because now I have a 3. Take a look. I have a 3 that cancels, and my 4's cancel. So I'm left with 1x is equal to, and then in my calculator, I can put this in exactly as you see it. So let me show you that quickly here. Hold on, I just have to bring my light down because my calculator doesn't light up really, really well. Okay, so in my calculator, what I want to show you here is I can put in 12 times, and I can use the N over D button, which you have on your fancy calculator I asked you to download. You can put in the 3 and the 4, and you get the answer of 9. Okay, so you can put it in just like that, and you get the answer right out. I don't expect you to do the fractions. What I do expect you to remember is that if this is 4 over 3, you have to multiply by what's called the reciprocal. Okay, and you did that on both sides. All right, last one, second to last one. We have 2 more. This is like a superfraction problem, okay? So anytime we have that, I'm going to write it down here to make myself a little bit more room. I'm going to put the top in parentheses. And then I'm going to say, how do I get rid of dividing by 3? Multiply by 3. These are going to cancel because it's 3 over 3. Draw on my wall. Add 8 to both sides. These cancel. X is equal to 2. Please stop. I am not talking to myself, by the way. I have my 7-year-old in the room supervising him right now, and he is not following directions. So, number 24, we've got parentheses. Here's my wall. I cannot combine the x and the minus 4. We know that from combining like terms. So I'm going to get rid of parentheses by distributing. You'll see a lot of these as we do more and more problems. So 3 times x, 3 times negative 4. Now this is going to be a 2-step equation. So I'm going to add 12 to both sides. Divide both sides by 3. And get my final answer of 6.